Good afternoon, Lugano. Thank you for being here today. My name is Alex Akers. I'm originally from Brooklyn, the kale-eating capital of New York City. I'm an iOS software engineer, and I currently live in Berlin, where I work on the Apple platforms team for Microsoft To Do. But enough about me. Last year marked the 10th anniversary of the iPhone's 2007 event. And you may not remember, but the original iPhone did not have this is on, is it? Yes, it is. The original iPhone didn't have an SDK. 10 years. It's been a long time. They told us to build web apps instead. Said, build web apps, and this is going to be the future. Little did they know that the following year, Apple would release the iPhone OS SDK 2, which allowed us to build native apps that integrate with previously inaccessible system features. Thus began the app era. It's been 10 years since, and I wanted to focus on these 10 years of iOS and iOS development. We're going to explore some of the key features and innovations that have contributed to the evolution of software development as we know it. Let's start with the multi-touch display. If you remember from the original iPhone announcement keynote, it wasn't just an iPod, widescreen iPod with touch controls. And it wasn't just a revolutionary mobile phone, and it wasn't just a breakthrough internet connector. It was all three, and it was the iPhone. And what set the iPhone apart from its then competitors was its approach to user interaction. Mobile devices at the time had static keyboards with physical buttons that required stylus interaction. But Jobs envisioned a mobile world not unlike the desktop one, where controls adapted to the user's needs. This is the concept that drives multi-touch. The ability to detect not a stylus, but multiple fingers set Apple years ahead of the competition when the iPhone was released. With a larger screen, the phone didn't require a pointing device, but a person could touch it with their finger to manipulate the interface, receiving immediately feedback. They could zoom a map with a pinch and pan the map with a flick. Thanks to multi-touch, phones became more fun too. Before the iPhone, phones were utility devices. They made calls, they sent text messages. You might have had a game like Snake on your phone, but at the end of the day, this was a device to communicate. With the entire screen available to developers, they were able to create immersive experiences with easy-to-use touch controls. Thanks to multi-touch, phones became more international as well. A keyboard that only appeared when necessary didn't require half of the device's real estate at all times. Furthermore, a screen could draw any character. Gone were the days of typing Japanese or Greek words with Roman character approximations because the phone simply lacked the proper characters. Many games that we know and love would not have been possible or as enjoyable without touchscreen controls. A GarageBand app without touch controls would never have been the same. If you play the piano or the drums, multi-touch allows musicians to be closer to the music than ever before. The App Store. Unlike desktop computers, Apple's mobile devices are programmed only to download and run apps from the App Store. Although this can be frustrating at times due to the tight control that Apple puts on its app marketplace, it solves a lot of problems for users and also for developers. This centralized hub is the one-stop shop, so to speak, for exploring, downloading, purchasing, and updating content for our iPhones. And while we may still learn about new apps from our friends or online, all of those apps can be found in the App Store. People don't have to look on the internet for a valid link or a trustworthy source to download from. They trust the apps that they download from the App Store have been curated by Apple and have not been tampered with in transit. As of iOS 11, Apple has even started featuring apps and games of the day, writing story-like articles in the Today tab of the App Store. And for developers, we don't have to submit apps to software aggregation sites, pay for servers to host binaries or validate licenses, and we don't have to build payment processing software. Apple takes care of all of this, letting us focus on coding amazing experiences for our users instead of dealing with all of that other stuff. Besides the initial purchase price, we get 70% from that. We also have other revenue sources as well. Although iAd was an interesting experiment, that's not what I'm talking about. Apple allows developers to put purchasable digital content into their apps. Stop me if you've heard this one, but children can sometimes get out of control when they play games on their iOS devices. Sometimes they unintentionally rack up charges after charges from in-app purchases. In the Jurassic Park app, for example, one child spent thousands of dollars upgrading virtual dinosaurs before his parents realized the damage. Apple did refund the money, but that's beside the point. In-app purchases are great because people are more likely to download a free app and later upgrade in the app when they already know that the additional features or improved experience will be worth the cost. For developers, this freemium model is easier to support in many ways because you no longer need a free or light version and a paid or pro version. This comes with all of the benefits of the App Store that I just mentioned that make it easier than selling directly to consumers. Developers can take advantage of 3 types of in-app purchases, depending on what functionality we want to unlock. Some in-app purchases are consumable, allowing users to upgrade their in-game experience with virtual items or additional currency. Others are non-consumable, like additional features, and can be restored from the App Store onto a new device. And not only can people pay for and subscriptions. My notes seem interesting. Okay, subscriptions allow periodical apps like newspapers or magazines to offer trials as well as full subscriptions in their apps. Not only can people pay for in-app purchases, but they can also pay for physical goods as well. Online shopping apps can allow people to buy their goods with traditional card-based payments, but they can also enable a new payment technology provided by iOS to pay for goods. And that leads us to Apple Pay. With Apple Pay, people can add a debit or credit card to their iPhones and Apple Watches. In this process, the devices are issued a unit-specific card number, which is stored encrypted in the device's secure enclave. When someone makes a purchase, the device generates a transaction-specific security code. This code, in addition to the device-specific card number, is transmitted to the vendor, not the original card information. This has many security benefits. Not only that, but the NFC chip doesn't broadcast payment data before it receives a signal from a payment terminal, and the user has authenticated with Touch ID or Face ID. This means that a malicious person can't skim the card details from a person's wallet as they walk by with a scanning device. When the phone is lost, the owner can remotely wipe the card information, or if the physical card is lost, Apple Pay card is still valid while the replacement is on its way. And developers can offer Apple Pay as a payment means in their own apps and now even websites. This provides a better experience for payment. This process is fast and works behind the scenes so that users can trust that their data is being handled securely thanks to Apple's security protocols. This gives users peace of mind, and it gives developers an easier way to handle payment data because they can offload the risky task of credit card processing to dedicated services who process the Apple Pay transaction securely. This trust has a cost. This peace of mind is important because we want our users to trust us and the apps that we make. Apple helps us to do that by ensuring that apps are separated into private, sandboxed environments. This separation keeps my app's user data safe from another, perhaps malicious app that may want to steal or tamper with information. And for developers, this means that we must take extra precautions to ensure that we behave within the sandbox limits. This is an example of the power of a platform to enforce their values through the ways such a platform behaves. Apple says time and time again how much it values users' privacy, and we can see that through the permission system that exists on iOS. This means that we must ask for the user's permission to access many types of data. And by many, I mean many. There are 15 data types that require explicit user consent before your apps can access them. Before the iPhone, it wasn't common for a device to ask for a person's permission before they accessed a feature or personal data. This doesn't solve every data collection problem, however. Since people can't see the code of the apps that they're running, there's no telling exactly what an app will do with the data it collects when you approve it. For example, an app could request permission to access GPS and location data, and then they would show you nearby places in your area. But they're sending this information to their servers where they store it for longer than they need to. Or an app could request access to your photos, and they would allow you to select when to upload to a social network when it's actually scanning the location data out of the photos to see where you've been, theoretically. Apple is definitely moving in the right direction with regards to sandboxing and permissions. But at the end of the day, the system relies on trust on both ends. Apple trusts the developers through the app review process, and the user must trust Apple's due diligence as well, as they must trust the app not to share their data in unforeseen ways. It's important to make sure that each and every person can experience the power of your app. To that effect, Apple has created a set of accessibility tools so that developers can ensure users' success with their app.
For example, VoiceOver allows people with visual impairments to interact with the screen if they have trouble seeing it.
But even for less serious cases, people can increase the font size with dynamic type. They can zoom in on the screen, increase contrast, and more. For people with restricted movement, switch control allows them to interact with an app's interface without precise screen interactions. The system will scan the screen and highlight the controls one by one, performing an action when a user activates a switch. A switch can be a screen tap, a Bluetooth button, a Bluetooth keyboard, or even a MIDI device. You can even set up the camera to detect head movement as a switch. This is a very powerful mechanism that allows users to interact with your apps without necessarily being able to touch the screen or the buttons on the screen. The only problem with Apple's accessibility efforts is they only go so far. For our users to have the best possible experience, we need to do our part so that our apps are accessible. The more stock controls that you use, such as buttons, switches, or table views, the more you get for free. The issue arises when you start to use more custom controls. That's when you have to put in extra effort to configure accessibility parameters. For example, on my team at Microsoft, we have minimum accessibility standards that an app must meet in order to be published. This includes minimum contrast ratios between text and background colors to make sure all text is legible. This means that we have to implement accessibility properties on our UI elements, especially the custom ones. And it means we have to make sure that we don't overcomplicate the main activities of our app with additional steps for the users to perform. Remember, Apple gives us the tools to make our apps accessible, but it's our job to audit our apps, make the necessary changes, and to design with accessibility in mind. In addition to these more fundamental technologies, Apple announced in iOS 11 both Core ML and ARKit, which have great potential to change the kinds of apps that we build. As we just saw in Megan's talk about machine learning, it can be a powerful tool to solve real-world problems, but it goes well beyond the classic cat-dog classifier and the is it a hot dog app. For example, a person with visual impairments could use the camera on their iPhone together with a trained Core ML model to detect objects in the real world around them. I could imagine a scenario where I pick up something at the supermarket and the camera says, "That's an apple," or "That's a banana," or "That's a tomato." Or even, "This product has dairy in it, but you're lactose intolerant. Are you sure this is what you want?" ARKit takes this one step further by allowing developers to integrate app experiences into the user's environment. Apple has made it very simple to integrate ARKit into our apps, which leverage the existing SceneKit 3D rendering engine with new world tracking features of the camera. It's worth remembering that ARKit apps aren't exactly new. For example, the Google Translate app has been around for years. You can use the camera in the app to translate text that you see on the world around you. But I would say that ARKit has created an entirely new category of apps. Before, there were not as many of them, nor did they work at the same scale that we have now. There are a lot of opportunities for developers in this space, ranging from simple entertainment value to real-world augmentation. For example, ARKit makes it possible to create immersive game experiences. This example is Conduct AR from Copenhagen-based studio Northplay. You can place a 3D train world in your living room and control the trains by tapping on the screen and guiding passengers to their destinations. And at WWDC last year, we saw Snapchat's new face filters, which take advantage of the new face tracking technology built into ARKit. Beyond using augmented reality for Snapchat or games, there are practical uses for it as well. London-based developer Andrew Hart created a supermarket guide in ARKit that can direct you to the aisle and location of a product, as well as recognize products for recommendation. So in this example, he picks up a chicken and it recommends a tikka masala sauce, and then it directs him in the supermarket to the aisle where the product is located. And there you have it. From the launch of the iPhone in 2007 with its multi-touch display to the paradigm-shifting ARKit and Core ML frameworks from the past year, these innovative features and breakthroughs of iOS have contributed to the evolution of software development as we know it. Since then, we have learned new concepts and technologies, and they have enabled us to create quality experiences for our users. Thank you for your time. I hope you enjoyed my talk. I'm happy to take any questions later if we have time, and you can also find me on Twitter and online in other ephemeral forums. Here's to the next 10 years of iOS development.